so this is another race experiment, but this is the continuous monitoring method. So again, fairly simple here. All we're going to do is perform this on a reaction which produces a gas. So it could be an acid and a metal, for example. And so what we do is we have a conical flask with a delivery tube attached to a gas syringe. Now we could also replace the gas syringe with a bucket full of water and then an upside down flask of some sort, and we could catch the gas in there. That's really messy. This is a much better method. And then what we're going to do is measure the volume of gas given off over time, and we're just going to do that using some kind of stop clock. And we would then plot a graph of volume versus time, and you'll get something which is curved, so it'll maybe look something-ish like that. Now, on a volume time graph, the rate of reaction is the gradient. Units for that gradient, because the gradient will be the difference in volume over the difference in time, so the units for this rate will be centimetres cubed per second. And the way we would measure a gradient, now if we're trying to find the initial rate, we would do this at time equals 0, and we would just draw a tangent. I'll use a ruler. I've not got one, so we'll see how this goes. Oh, that's not too bad. To draw a straight line to best reflect the angle of the curve at time equals 0. That's if you're finding the initial rate. If you was finding the rate at time equals 20, you would just draw a tangent at time equals 20 to best reflect the angle of the curve there. So read the question and look at what rate they're asking you to find. We then, to find our rate, we find the gradient, which is the difference in volume over the difference in time. Now, when you do your tangent, make it quite big, because that will minimise your human error. If you make your tangent that long, then that will maximise your human error, and so your answer will be off by a little bit more. And they will give you a little bit of leeway on this, but not like infinite leeway. So my difference in volume is the difference from here to here. So here's my change in volume. My difference in time is from here to here. So there's my delta T. Get those numbers, whap it in a calculator, and you'll get your rate in centimetres cubed per second. If they was asked you to do this question, it would probably be a 6-mark levelled one, where they say describe the experiment. They'd often say include an equipment list with this as well. So just don't forget the delivery tube, gas syringe, conical flask, and the one people tend to forget is the stop clock, because you obviously need to time when the volume's being given off.